So our last example will be one where we explore imperfect price discrimination, specifically third-degree price discrimination, where we can charge different prices to different groups of consumers. So in this problem, we have a pharmaceutical company who sells its product both in the US and in Europe, but this applies to any situation where you have different markets, and those markets don't necessarily have to be in different geographic locations. It could be, for example, offering a different price to students to go to the movies versus non-students. So here we have a constant marginal cost at $10 and then two different demand curves for each of these market segments. And what we want to do is to first show what the firm will do if they can price discriminate, if they can charge different prices in each market, and then show how they will maximize profits if they have to have uniform pricing. So if the firm can charge different prices in each market, they will simply treat each market separately and maximize profit, choosing price and quantity in each market to maximize profit in that market. So what we're going to do here really is to say, in Europe, we're going to set marginal revenue equal to marginal cost, and in the US, we'll also set marginal revenue equal to marginal cost. Notice that we've written here the demand curves, and in order to calculate marginal revenue, we would need to rearrange them to be inverse demand curves. In this case, it's pretty easy to do, right? I've got this, and then total revenue is 70 minus Q times Q. So I got 70Q minus Q squared. So marginal revenue is 70 minus 2QE. And then same thing in the US. I have to rearrange, so it's P equals, and then I can calculate total revenue and marginal revenue. So I've got my marginal revenue here on each graph. And all right. So now in each market, we will maximize profit. So if we set marginal revenue equal to marginal cost, then we can solve for the monopoly quantity in each market. So in Europe, we will want to sell 30 units, charging a price of 40. And in the US, we want to sell 50 units, charging a price of 60. So profit will be our total revenue minus total cost. And here total cost, because we don't have any fixed cost in this problem, we just have a $10 marginal cost. So we can calculate our total cost just as $10 times the number of units that we've sold. So we got $900 from the European market, and from the US market, we get 60 times 50 minus 10 times 50, which gives us $2,500 in profit. So total profit is going to be $3,400, and you could also go through and calculate surplus in this example in each market to get total surplus. Okay, so that seems pretty straightforward in terms of method. For uniform pricing, we need to think of these two different markets as one market to set one price and one quantity spread across the two different groups. And to do that, we need to aggregate the demand curves to one market demand curve, which luckily you have some experience doing, so hopefully this will not be too difficult. Recall that we need to pay attention to the highest price that people are willing to pay in these markets. because that's the choke price, and our market demand curve is actually going to be discontinuous or kink at those prices. So when we write out our total demand, we can see that it will be 0 if the price is greater than 110. If the price is between 70 and 110, then we will have demand just from the US market. So the demand curve would be 110 minus price. And if the price is less than 70, then we'll have demand from both markets. So that would be 180 minus 2 times price. So we don't know exactly where we are on this market demand curve. What we'll do is we will assume we are here, and then we'll just check it once we get an answer for price. So we'll assume we're on the combined market demand curve, and then we'll calculate our marginal revenue. First, we have to do total revenue. And to do that, we need to rearrange our demand curve here. So what we have is Q equals 180 minus 2P. So if I write inverse demand, that tells me that I've got 90 minus 0.5 Q. So my total revenue is going to be 90 minus 0.5 Q times Q. And then when I find my marginal revenue, it's going to be 90 minus Q. And then I'll set that equal to marginal cost. And I get Q equals 80. And then I can plug that back in to get my price. And I would see that my price here is 50. So now I check, is this price in the price range that I assumed? Yes, it is. Less than 70. So this is the segment of the demand curve that I am on. Okay, so now what we want to do is think about how this new price at 50 has impacted people in both of these markets. So you can see that for the Europeans, the price has gone up from 40 to 50, meaning that the quantity in the European market has gone down to 20, right? So we have a decrease in quantity in the European market as we have this increase in price in Europe. We have a decrease in price in the US. It used to be 60 and now it's 50. So we should see an increase in quantity in the US. And we see that the quantity has gone up from 50 to 60. So you can see we really have here, we've sold actually the same quantity of product as before, but the distribution across the markets is different. If we have uniform pricing, we actually end up selling even less in Europe because those customers have a lower willingness to pay. To sum up, we have this increase in prices, a decrease in sales, and a decrease in consumer surplus. In the US, we have a decrease in prices and an increase in sales. So we're going to have an increase in consumer surplus. And if we look at profit here, I've got 50 times 80 minus 10 times 80. I can see that the firm will be earning less profit in this case, of course, because they're unable to price discriminate. Okay, and this benefits consumers in the high willingness to pay group and it harms consumers in the low willingness to pay group.